This is Steve Saltwick, and welcome to Your Brain, a Personal Tour, Seminar 5. Today we talk about the human brain in all its glory. The goal of the seminar will be to investigate and present the unique capabilities of the human brain that give rise to the vibrant culture around us. We'll see that the truly unique aspects of the human brain are few in number, just 3 capabilities in my opinion. Over thousands of generations, each one of those 3 capabilities had tremendous power to bring about the culture we experience today. These capabilities build upon the primate brain capabilities we covered in Seminar 4. The subtitle is about the skill of teaching and its impact on the human brain and human culture. Teaching and pedagogy are underappreciated aspects of neuropsychological research. We'll see that they had a significant influence on our brain and culture as it developed, which is a wonderful way to begin this seminar to a class of lifelong learners. Welcome. I hope you enjoy the seminar. For those of you that enjoyed the opening sequence, I present a roster of the images of 24 brains that have changed the world, and their attributions for your reference. I challenge you to think about the images you would place on your personal slide of human culture. It's a fascinating exercise, and I encourage you to try it. For those who are interested in more information about these brains, I've published a summary of my reasons for inclusion and some links for more information. I want to give special thanks to Mrs. Carol McGuire of the Quest Lifelong Learning Program at the University of Texas at Austin. She challenged me to include more women in the sequence. Her first suggestion was all women, but I demurred on that one. From that challenge, I redoubled my effort to be as inclusive across as many dimensions as possible. I'm not there yet, but this sequence has greatly benefited from Miss McGuire's suggestions, and I thank her for that. I've also added 2 new books to the reading list. The first, Two Heads, is the one book I hope all in the seminar will read. It is simply outstanding. Please don't let the format put you off. It is a graphic novel, but it's not a comic book. It's a serious presentation of how our brains, interact with other human brains by 2 of the foremost researchers in the field. I believe the authors will be future Nobel Prize winners. The second book is a wonderful account of gesture, the first movement of language. There's a fascinating information about gestures and how they can shape our thoughts and how it was the seed of the human unique capability for language. One of those 3 unique human capabilities can actually be experienced as you watch this video. As far back as 1944, researchers found that they could evoke mental state attributions when viewers watched a silent animation of very simple shapes like triangles or circles. In this film, I see a mother triangle, the large red one, trying to convince her child triangle, the little one, to leave the nest. The mother coaxes her child out. The child is fearful of leaving the nest and must be coached. In fact, even prevented from coming back in at one point. Then the mother and the child experience the joy of playing outside of the nest. Is that what you saw? Now I want you to think about this. We were watching 2 triangles. Your brain was projecting intention and emotion on the lifeless but cute geometric forms. This is called mentalizing, and it's thought to be a key unique human trait. Your dog or cat does not do this. You may do it to your dog or your cat, but your dog does not do it back. As we shall see shortly, this trait sets up a massive amount of human cultural evolution. But let's introduce the other two human unique capabilities first. Here we see the three capabilities that I assert are unique to the human brain. 1. Mentalizing, what we've just talked about. It's what your brain did to those triangles, and it's part of a repertoire called theory of mind. Your brain devotes significant resources in thinking about other brains' thinkings or feelings. This broad set of capability is termed theory of mind. I'm going to call it TOM for short. 2. Language is the second capability. Yes, Eric the parrot can talk, and several primates can use sign language, but no set of brains on this planet is so wired for language as the human brain. Human infants show amazing capabilities and behavior that far outstrip any other species. And then finally, 3, natural pedagogy. It's human communication and theory of mind specifically adapted for the efficient transmission of cultural knowledge among a generation and across generations. Knowledge that would be almost impossible to learn by imitation alone, and then can be passed using pedagogy from one generation to the next, so that the ever-expanding corpus of human knowledge can accumulate across thousands of generations, and hence give us the medicine, airplanes, iPhones, and unfortunately telemarketing calls. In my reading of the literature, these three capabilities are the essential set of human unique traits which set us apart from all other species. But don't forget, the human brain builds upon expanded capabilities in the brains of our primate ancestors. We covered those in Seminar 4. There were 4 of them: multisensory evaluation of future outcomes, the learning of abstract categories, focused attention on a goal that was several steps removed from the current behavior, and strategies to deal with success and the unexpected. The human culture we experience today is a combination of the unique capabilities of our human brain and the foundational capabilities of our primate ancestors. Now let's take a look at the theory of mind, or mentalizing capability of your brain in more detail. And we'll use an example. I want you to think about a situation in perhaps an earlier stage of your life. You go to the laundromat to wash your clothes, and one day you go to the laundromat and you see this. A stranger taking your clothes out of the dryer. With only a few seconds of perceptual data about this stranger, a typical brain will mentalize. Maybe she's going to steal my clothes. Or maybe she's feeling amazingly generous and she just does this as a random act of kindness. Or maybe she falsely thinks the clothes are hers. This native capability to reason about other people's action in terms of mental states, their thoughts, their beliefs, their desires, their emotions and intentions is called a theory of mind. This capability is not present in a newborn baby. It develops. Using a test called the false belief test, researchers can show that a typical human child develops the capability for a theory of mind around the age of 4. A false belief test probes whether the child can represent in their brain a false belief held in another brain, imaginary or real. Let's look at 2 examples. The first will be from a 3-year-old undergoing this false belief test, and the second will be a 5-year-old. And note the difference.
Yes!
This is Sally, and this is Anne. All right? Now, Sally comes in with her marble. Sally puts her marble into the basket and goes out. Anne comes and gets the marble, and she puts the marble in the box. Here comes Sally. Here comes Sally. Now, where will Sally look for the marble?
Go, Sally.
You got it for her! Hooray!
The ball in the box. Can you open the box for me? Can you close it? Joey decides to go outside. And then May takes the ball and she puts it in the basket. And then Joey comes back inside. And where do you think he'll look for the ball?
In here.
In there. Why will he look in there?
Because that's where I put the ball.
And where is it really?
In the basket.
On the basis of this test, it's clear that a 5-year-old human brain can understand the situation where a different brain, yes, an imaginary brain, but still a different brain nonetheless, can have a false belief. This is a very consistent result. It's shown both in rural children and urban children, in Western societies. It's been found in Peru, India, Samoa, and Thailand. It's even been found in the hunter-gatherer children of Cameroon. There are differences in acquisition. Children presenting autism spectrum disorder show a significant delay in the acquisition of this capability, and we'll discuss that in a later seminar. Do non-human primates have a theory of mind? David Premack, a legendary researcher on primate learning, and Doug Gillian, a UT graduate, reported one example of a theory of mind in a famous chimp, Sarah, shown here at age 50. However, in the vast majority of past experiments, results show that the non-human primate and other animals just don't quite have the capability as shown on the video. But, as they say in many things in science, it's not quite that simple. Recent research has shown tantalizing results for a theory of mind capability in non-human primates. These results have caused quite a stir in the research community. However, most of the results depend on measuring anticipatory looking, that is to say, measuring where and how long monkeys looked at an experimental situation. We can't ask the monkey about what some other monkey is thinking, so we measure where he is looking. And when we do this, we get mixed results. While a chimp may or may not pass the false belief test, several AI models pass it. Some can detect faux pas. Some can detect irony. Given the rate of change in AI, it seems likely that more and more models will acquire a theory of mind. Does that make them conscious? I don't know, but it sure is interesting. Since this is my tour, you're going to get my story of how to interpret these results. I believe the body of research tells us that theory of mind is a composite of at least 2 levels of perspective taking. Non-human primates and other animals have what may be called level 1 perspective taking. Humans are the only animals to date to show level 2 form of perspective taking. What's the difference? Well, let's see. Level 1 perspective taking is building a common view of space for 2 animals. Here, a woman sits behind the far side of a blind. To her left, there's a chicken in plain view, but behind the blind is a kitten. The blind box blocks her view of the kitten. An observer who has level 1 perspective taking is shown as Sherlock Holmes on the right. He can correctly deduce that the woman can see the chicken but not see the kitten, even though he can see the kitten. You might think this is obvious, but a 2 to 3-year-old child often lacks level 1 perspective taking. Now, to show level 2 perspective taking, we have to set up a thought experiment. This experiment will synthesize all the research I've read on the topic. It may be make-believe, but it represents the clearest view I have as of today. I need to introduce two participants in the experiment. Kaylee, one of our dogs, is the first participant, and you need to know she loves treats. And then our second is Wiggin, our other dog. Wiggin loves toys more than treats. So here's our experiment on level 2 perspective taking. Our participants will predict what will Wiggin choose, toys or treats. One participant, Kaylee, and for this experiment only, we grant the ability to talk. The other participant will be Becky, my wife. Okay? What does Kaylee predict? Well, Kaylee goes, I love treats, therefore all dogs love treats, therefore Wiggin will choose a treat. Becky predicts Wiggin will choose a toy, since she knows Wiggin loves toys. So what does Wiggin pick? The toy. Becky was able to see the choice like Wiggin sees the choice. She got inside his head and imagined thinking like she thought he thought. That's level 2 perspective taking. Walking a mile in their shoes or paws. Note that Kaylee believes all dogs think like her, and many do. But Kaylee just can't think about another dog thinking differently than her. Being able to think about someone else's perspective has massive impact on human culture. Some big ones are cooperative hunting. Early humans could coordinate their hunting. If you knew your hunting pal had the best shot to take down a prey, then you could assist by driving the animal to the best place for him to kill it. If you could imagine a village boy was thinking about a problem, you could teach them more effectively. And if you could think about someone else thinking, well, you would realize that they could be thinking about you, and you would care what they were thinking about you. And voila, we have the grounds for reputation management. Theory of mind level 2 is a major force in human culture and beautifully but densely described in the book A Natural History of Human Thinking by Michael Tomasello. If you're interested in this topic and don't mind technical language, then this is the book for you. If we scan the brains of human beings during the performance of false belief tasks, we can see activation of a specific brain circuit as shown here. I highlight one area in particular called the temporoparietal junction, or TPJ for short. Note there's a significant activity on both sides of the brain when we scan during a false belief test. This circuit is activated when your brain has to consider another brain's perspective or belief. It is not activated when your brain considers a false photograph, say a picture of a signpost pointing the wrong way or indicating the wrong city. The effect is very robust, and it's been replicated by several labs. Self-awareness and consciousness are major topics of brain research, and rightly so. A key question for the understanding of the brain is, how does consciousness arise? It's the hard problem of neuroscience, and one that we must creep up on carefully. An intriguing result is that the recognition of your own face activates the theory of mind network. My interpretation of this effect is it's one brain is reflecting on itself as another brain. This kind of processing by your brain may be impactful in the construction of a conscious experience. It is the brain being aware of itself. Perhaps we should rewrite René Descartes' famous expression, I think, therefore I am, into a slightly different formulation. I'm aware of my thoughts, therefore I am human. More research on this is clearly needed, but it's a promising area of research into human consciousness. Now, we've talked a great deal about scanning human brains, and I want to be sure we're aware of the power and limitations of the tool. The machine we use is called a magnetic resonance imager, or MRI machine for short. An MRI machine can image virtually any soft tissue of the body. And when we want to study the brain, we use a technique of MRI called functional MRI, a technique where we measure changes in energy metabolism, mainly blood flow, to indicate brain activation. This machine is rather daunting. It makes loud noises as it generates magnetic fields in order to measure blood flow. If you've never experienced what one is like, it can be quite unsettling, and I have some sounds here to illustrate. Even with earplugs, the noises can be quite loud. Your skull is inside a donut and it can be quite claustrophobic. Therefore, there's a running joke in the neuropsychology area that when you study fMRI, you can get artifacts, as in this cartoon, showing, that performing an MRI during a memory task, can have artifacts of claustrophobia and the removal of jewelry. So we need to keep in mind that, there could be artifacts that we need to take into account. The other big caveat is that we need to be aware of with fMRI is that fMRI is correlation. Correlation is a mathematical measure of how two things vary together over time. It's a very useful measure in many studies, but just because two measurements vary together over time does not mean that one causes the other. Billy, on the left, is upset because every time the seatbelt sign comes on, the airplane ride gets bumpy. The graph on the right shows a very highly correlated set of measurements between the films of Nicolas Cage and the number of people who drowned in a pool. Now, one of the important rules in this area of study is that correlation is not necessarily causation. Nicolas Cage films are not causing people to drown, and turning on a seatbelt sign turning it off will not stop an airplane turbulence. We just need to be aware of this, and when we look at correlational studies using fMRI, theories about what is causing one variable to change when another is varied can be bolstered if we use multiple types of data, say fMRI, stimulation, deactivation, to show the same effect. Don't get me wrong, fMRI is a powerful tool. We just need to be aware of its limitations as we look at human brain scans. A closely related capability that we do share with many, but not all animals, is the expression of empathy. Mother Nature has endowed many of our relatives with this social emotion, including primates, elephants, canines, that means dogs and wolves, but even certain species of birds, like ravens and magpies, and some rodents, like the prairie voles shown here. As it turns out, there's a separate neural circuit for this capability, different from the theory of mind circuit just shown. I'll explore that next. Empathy is the ability to share the feelings of another brain. If you scan the brain of a subject who is directly experiencing some kind of pain sensation and compare that scan to one where the subject is observing someone in pain, you'll find a high level of brain activity in common. They're shown here on the scan in orange. That means that empathy is truly a vicarious experience. Bill Clinton got it right. You really do feel their pain, at least at a high cortical level. This circuit is separate from the theory of mind network, but there are complications and overlaps. If you test for empathy, as shown in the lower right, which involves a married couple, one is in the brain scanner and one is outside, and you cue for pain in the abstract, for example, using arrows, brain activity shows activity in the empathy circuit and the theory of mind network. But if you cue with a concrete cue, like example, a prick to the hand or stubbing of a toe, then the theory of mind network is not active, but the empathy circuit and the mirror network are active. We cover the mirror actor network in Seminar 2. It's as if the motor act is being analyzed for its intention, and planning is active on how to avoid this particular painful stimulus. So empathy is a complex, multidimensional process in your brain that can be modulated by surprising events. One of the most intriguing modulators of the empathy circuit is social factors. To show this, we're going to do two things. The first is we're going to have a subject play an economic game with either a fair or an unfair research assistant before the brain scan. We're then going to scan their brains as we apply pain to the research assistant. At least that's what the subject believes. Females are highly empathetic, and that's shown in the purple bars on the left. females are less empathetic for the unfair player, but compare that to the males. Males are positively revengeful. Males have no empathy for the unfair player. In fact, they want to punish them. Alternatively, we could measure empathy when the subject is either within or without a group. In this instance, we study males where membership in the in-group means that the subject and the research assistant are rooting for the same soccer or football team. Being a member of the out-group means rooting for a different team. You can see that males are much more empathetic to members of their own group compared to members of an out-group. The effect is very consistent. It applies also to females in different situations, and this can be called an us versus them effect. Us versus them effects are present in a wide variety of animals, including humans, and they bring about some strange aspect of behaviors. A wonderful example about the strange effects occurred at the set of the Hollywood movie Planet of the Apes. Now, I'm old enough to remember well this movie. If you're not, hit the Google button. Actors had to eat lunch in their makeup. But there was a fascinating aspect to lunch. Actors representing chimps ate together with actors representing chimps. Actors representing gorillas ate together, and the same with orangutans. There was not a rule about doing this. They just did it spontaneously. The us of the chimps didn't want to eat lunch with the them of the gorillas. Oh, no. And now, in all likelihood, the actors were not primate racist. So what was going on? Well, it turns out that your brain has an ancient fundamental neural pathway to processing us versus them hallmarks. Let's just look at a few of those hallmarks. To demonstrate that such neural pathways in your brain are fundamental, we can use reaction time experiments. In these experiments, an image is presented for about 1/10 of a second. The images are subliminal. The viewer is not certain they've really seen anything in particular. We measure the influence of the presented image on a subsequent task, and if there is an influence, we conclude that the unconscious impact was on a brain process. What kinds of aspects influence your brain without conscious knowledge? Well, gender, ethnicity, social status, and race. In each case, your brain is most sensitive to the dimension that is not you. In other words, if you're male, you react faster to female faces. If Asian, faster to non-Asian. If you're African American, faster to Caucasian. Your brain instantly reacts to these dimensions via an ancient pathway laid down by Mother Nature. From an evolutionary viewpoint, such reactions were clearly valuable. But in today's society, such reactions support the development of stereotypes and further the divide between us and them. Is there anything we can do to moderate such an effect? Well, yes, and I want to use the automatic manual mode analogy again. I use a very effective ad campaign to capture the essence of the effect. Your brain has an automatic mode that quickly categorizes faces and other objects along an us, same as me, and them, different than me, dimension of gender, race, etc. Again, in evolutionary times, this had survival benefit, and the brain pathways were conserved to the present day. The net effect of these pathways is to support the development of stereotypes that can be counter to maximum productive societies. The way to break through these is to bring in the deliberative aspect of other areas of the brain to make an anonymous face a person. The more your brain considers the face as a specific person with attributes that your brain can relate to, then the less you're going to get stereotypical behavior. Now note, your brain pathways are still signaling us and them, but the rest of your brain is overriding them with specific information that blocks or reduces stereotypical reactive behavior. And that's a good thing, and it's something all of us can do. It's work, but it's worth it. Time now for Homer to join us and give us his thought. Homer is incredulous that everyone doesn't think like him. Homer is stuck in level 1 perspective taking. Thankfully, Homer was not the first human. Level 2 perspective taking, thinking about the thoughts of others, is a unique human skill as of today, and it underlies much of our culture. But an ancient pathway is useful for the emergence of human culture, but it can give rise to stereotyping and other unhelpful behaviors in the modern world. Thankfully, such behaviors can be overridden. They're still there, but moderated by the perspective of other brains. Now let's turn our attention to the second unique aspect of human brains, the facility for language. No other species seems to be wired for language like humans, whether it's speech, gesture, or writing like the Mayan glyphs. Our brains are endowed with the spectrum of landing skills that are clearly at the apex of animal capability. Let's see what that means in more detail. Now, years ago, there was a simple story to the way your brain processed language. On the left side of your head, there were two main areas that fundamentally process speech. Broca's area was responsible for how you said what you wanted to say, and Wernicke's area interpreted the speech that you heard. Notice the path between the two, which bypassed the vocal cords, and that's the path for the inner voice in your head. Today, this diagram is still mostly valid, but we need to change the words related to speech and hearing to words associated with communication. Because Broca's area not only helps your brain figure out what to say out loud, it's also involved if you sign your speech. Likewise, Wernicke's area is not just about hearing words, but about reading words. And even if you pantomime your speech, in this instance, let's open a jar, Broca's area seems to be a pattern generator for motor programs to communicate either in speech, gesture, or pantomime. Likewise, Wernicke's area is not just about hearing words, but also about reading words, or surprisingly, about understanding pantomime's words. In this instance, the phrase, "I've got it." This is a fascinating area of study right now. I want to emphasize that these language areas are not just about making the sounds of speech. They seem to be trying to communicate a thought via whatever motor program is most efficient or available in the communication path. Now, in over 95% of the population, regardless of handedness, the majority of complex language processing is contained in the left hemisphere of your brain. We know this from split brain patients. Split brain patients have had their brains transected for the treatment of epilepsy or some other neurological condition. Also recall that the brain half controls the contralateral side of the body. Therefore, the left side of your brain controls the right side of your body. The right side of your brain controls the left side of your body. With split brain patients, we can present separate pictures to each side of the brain and then query the subject for how they're processed. The right brain is not completely absent language skills. However, the right side skills are minimal. It can't process complex grammar, but it can read words. Theory of mind attributes offer an excellent foundation for a framework of language. In such a framework, language is a tool for transmitting one brain's mental state to another. Speech is probably the most effective modality, but gesture, pantomime, and writing can also be effective. If this framework is reasonable, then we should see a coupling or synchrony between a speaker's brain and a listener's brain when we scan the brains when they listen to a story. And guess what? That's exactly what we see. On the right side of this diagram, the areas in blue depict synchronization between a speaker's brain and a listener's brain when the speaker relays a story. The synchrony is reflected in correlation of the brain scans. Yes, correlation is not necessarily causation, so it's appropriate to ask if there's another compelling result that would show a coupling between a speaker's brain and a listener's brain, and there are. In this experiment, there's one story. The story has been translated from English into Russian. There are two classes of listeners, native Russian speakers, and native English speakers. There's very little coupling between the brains of the two classes of listeners when just the Russian story is played. Coupling is shown in orange on the brain diagram. However, if we play the story in Russian to Russian speakers and we play the story in English to English speakers, there's a significant correlation between the brains shown in orange. The brains are locking on to the meaning of the stories. You can see the same effect with people watching a movie together. The brains are synchronizing to the meaning of the story. Theory of mind circuits are active in language processing as the listener considers the mental state of the speaker. Let's take an example while we scan the brain of a listener. In the first test, the listener asks a simple, direct question, and here's a simple, direct answer to his question. The answer requires no evaluation to the mental state of the speaker. Is it hard to give a good presentation? The answer is simple. It is hard to give a good presentation. It's a matter of fact. In the second case, the listener asks a different question but gets the same answer, the meaning of which requires consideration of the mental state of the speaker. In this instance, theory of mind circuits, especially the right temporoparietal junction, are highly active, and they're active only in this situation. Listener brains are always evaluating the incoming communication for triggers to consider a speaker's mental state. This assists the listener's brain in coming, to a consideration of what is in the speaker's brain. Recent research has shown that there's an amazing similarity of the semantic maps between brains. Research at the University of California, Berkeley published a dramatic map of this, a cartography of word meanings. I'll play a video of this presentation in just a minute, but I want to emphasize the findings. The meaning of words, the semantics, are grouped in similar areas across different brains. These groupings imply a common framework of meanings, at least for the brains of Berkeley students. It'll be fascinating to see if this holds up across cultures different from Berkeley. And there just might be a lot of cultures different than Berkeley. But let's take a look at the video now.
This is a map of someone's brain, showing roughly which areas respond when they hear different words. For example, there's a small area in the middle frontal gyrus that reliably responds to hearing the word top. But it's not just one word, one location. A single word can activate a whole range of different brain regions. So we find the word top in a bit of brain that seems to respond to words associated with clothing and appearances, but also here with numbers and measurements, and here with buildings and places. We usually think of language as being restricted to certain sections, like the temporal lobe. So researchers were surprised to find activity all across the brain and in both hemispheres. The map was made by scientists at the University of California, Berkeley. They put volunteers in an MRI scanner and had them listen to stories for 2 hours.
Back in the front again, deep, and she pulls out a pack of matches that have been laundered at least once.
By monitoring blood flow to different parts of the brain, they worked out which places were responding to the meaning of the words, the semantics. They found that different bits of the brain responded to different kinds of words and concepts. And they could group them into rough categories, shown here by the different colours. Dark green bits, for example, were most activated by words to do with numbers, red bits by social words. Here in the right temporoparietal junction, this speck of brain, just a few millimetres across, was found to respond to words like wife, mother, pregnant, and family. And this bit just next door responds to some of the same social words like family and wife, but also words to do with places and people like house and owner. Generally, the concepts represented in each brain region relate to other functions that scientists already know about, So words to do with how things look, such as stripes, are likely to be found near the visual cortex. And although each individual's map is different, looking at these three brains, it's clear that different people have the same kinds of concepts in the same kinds of places. This is the first time we've been able to map the semantic systems of the brain in such detail, discovering that words are grouped by meaning, and revealing just how complicated and widespread the word maps in our heads really are. And the brain map is available online for anyone to explore.
The use of this technology has opened up possibilities that are not just frightening, but stupid. Here's a slide from a Facebook developers conference. Facebook wants to use brain decoders of information to allow you to tweet or send messages directly from your brain. You think it, you tweet it. Now that's a terrible idea in general. It could be used to help paralyze people, and we'll see that, but not as a general function of social media. We can use such facts to implement brain decoders to help us glimpse some of the inner workings of the mind. For example, this is a movie of a flaming dessert we show to a subject. The subject is in an MRI machine and we monitor the brain with some complicated software. Let's just call the software Magic, because that's what it is. The Magic software then generates a movie of what the subject has seen, given only the activity of the brain. Here we see the output of such a decoder when the subject is watching the movie clips. The system is called BrainFlix, and it's very, very smart. But as many of you know, such software can make mistakes, like here. The subject was shown a movie of the moon, and BrainFlix decoded the scene with humans. Now, the video of the moon might have evoked memories of a particular person, but there was clearly, this is not a faithful rendering of what the subject saw. This kind of software magic is creating real hope for restoring function. For example, sight. Neuralink, a local company, received FDA breakthrough device designation for a product termed BlindSight. This device uses software magic and implantable electrodes to bring vision to those with optic nerve damage, for example, cancer, or even those who have been born blind. They don't see what we see, but they see well enough to lead a productive life, and that's a very good thing. One last point in this segment. Your brain creates a model of semantics, or meanings, with what is termed a hub-and-spoke system in your temporal cortex, the bit of brain by your temples. Of note is that each attribute of a concept or word is individually expressed in the appropriate sensory or motor area of the brain and then collected into a multimodal hub at the end of your temporal lobe. This kind of model has been very successful at explaining brain operations, and I want to emphasize two major points. First, the meaning of a word or concept is multimodal. It has aspects of sound, sight, and other senses. It also has aspects of how it's used or function, how it's gripped, praxis, and how it's pronounced. This is a critical insight from the model of semantic memory. Second, the hub that receives all this information represents the concept as the sum of all these factors. This concept corresponds well to how the brain works normally, and when the hub is damaged, the patient may lose the memory of how to handle it. For example, they lost praxis. But you still might know what it is when you look at it, or vice versa. And that's exactly the symptoms we see. Time for Homer to weigh in again. Homer has 2 points, and they are as follows. First, consider language as a tool to transmit the mental state from one brain to another brain. This transmittal can range from hard coupling, so that we're, quote, on the same page, to manipulation about lying about your mental state. This is a kind of theory of mind framework which has great utility in understanding the brain. And second, semantics, or the meaning of words, in normal brains seem to be stored in roughly standard locations, at least among the brains sampled so far. Note that they're all in the same culture so far. More experiments are needed, and it will be extremely interesting to see the results from varying cultures or from psychological dysfunctions. There's a large body of research which correlates and concludes that humans are the only species which, as a whole, utilize a communication framework allowing and facilitating the transfer of knowledge to novices, not just family members, but widespread members of tribes or larger social groups. We're going to call this framework natural pedagogy, and we'll introduce its key characteristics in this, our last section. Those key characteristics are 1. Infants are wired to learn from birth onward. 2. Theory of mind, language, and mirror circuitry in the human brain makes it possible to mirror the intent of a demonstrator, for example, in the manufacturing of tools. And 3. The rewarding effect of being understood enabled a positive feedback loop of pedagogy. This cycle gave humans an evolutionary advantage which over thousands of generations resulted in the culture we see today. This is a new area of research, and I think it offers stunning insights into human culture. The first capability shown by human infants for supporting pedagogy is sensitivity to what is called ostensive gestures. This capability is present at 4 months of age and might even be present earlier. An ostensive gesture is a gesture that signifies intentional communication. A good example is direct eye contact or a raised eyebrow. Human infants are very sensitive to these gestures, as shown on this slide. The top tracing is an EEG brain scan of a 4-month-old infant under 2 conditions. The top row is the infant seeing a face with diverted gaze, which then raises an eyebrow and smiles. As you can see, there's no significant EEG or brain activation. In the bottom row, the reaction of the infant to the same eyebrow raise and smile is shown, but this time the face is directly gazing at the infant. Both gestures significantly affect the EEG. Similar effects have been shown for other primary ostensive gestures, motherese or baby talk being a good example. Net, the infant is barely out of the womb, but is very much in tune with efforts to communicate with them. So, look directly at your infant grandkids and smile, coo, and say baby talk. It's good for them. By 6 months of age, an infant is reliably using ostensive gestures to initiate gaze following. In this example, an experimenter uses eye contact in the top row, or motherese, that is baby talk, in the bottom row, to signal an imminent communication, a direct gaze at one of 2 toys. Such an ostensive gesture, eye contact, or motherese, results in the infant reliably following the gaze towards the ball. If there's no ostensive gesture, no eye contact, or infant-directed greeting, then there's no gaze following. Now, to ensure that the looking of the infant was equivalent between the 2 infants, a colorful cartoon was placed on the head of the experimenter. The flower-looking symbol that you see on top of the experimenter's head is to ensure the infant did not turn and orient towards the experimenter and that the situation was similar between eye contact and no contact. By 9 months of age, the infant has mastered the distinction between ostensive pointing and a simple reaching for an object. The interpretation is that the infant understands the intention of the motor act of reaching, but does not attach any importance to the object. The ostensive gesture of pointing signals that the object was important. I want to pause here and emphasize just how much our culture depends on pedagogy. I present a perceptive quote from an excellent Scientific American article. Humans can go to the moon while chimps work on termite moons. because of the capacity to teach the next generation that skills and culture coming from pedagogy. These capabilities of our brain sets the stage for pedagogy in ancient times. A good way to see that impact is to look at tool making in the Stone Age. This slide shows a simple stone cutting tool that was found in the historical record of about 2 million years ago. The tool is classified as an Oldowan tool, and it's very, very crude. It's made with flaking chips off a coarse stone, with strikes from a hammerstone. Research in the lab has demonstrated that primates like chimps and monkeys can create Oldowan tools merely by imitating the striking movements of the hammerstone as demonstrated by a tool maker. There's no need for ostensive gestures. There's no need for understanding the intention of the demonstrator. It's simply a matter of imitation. That was probably the state of play 2 million years ago. Between 2 million and 700,000 years ago, tool making evolved to the diagram you see on this slide. Two workers cooperate to work on a much more advanced stone cutting tool called an Acheulean blade. The blade is far more effective than the previous Oldowan tools. It could be hafted, that is, attached to a pole or handle to form a very effective killing weapon. With such a weapon, larger prey could be killed and consumed. The important point here is that research has shown that merely imitating the motor acts of a demonstrator will not produce a good tool. The intent of the tool maker needs to be copied. The sharp edge of the fashioned stone will vary from coarse stone to coarse stone. Imitation will simply not cut a good tool. Okay, it's time for Homer to make his final appearance in this particular seminar. Homer has two simple points to make. The first is that humans are born wired to learn. This is an essential element and driver of our evolution and culture. And the second point is that pedagogy is truly a divine calling. It was and is essential to the positive development of human culture. Even though it may be used to take people to the dark side, its impacts are unappreciated in the research literature, both in terms of human neuropsychology and anthropology. Further scholarly research will be much more appreciated in order to better understand this element or evolution in culture. This concludes Seminar 5. I hope you enjoyed it. In Seminar 6, our final seminar, we'll talk about how the ecosystem of your brain can go wrong, from aging, from damage by stroke, or other trauma. I promise it won't be a downer. We'll also cover the most recent research on the repair of function. There are many reasons to be excited about this area, while admittedly there's still much to be done. The subtitle of the seminar is Dog Walking and the Jedi Monkey. You'll have to wait on the Jedi Monkey bit, but you'll be amazed at what dog walking can do to repair an aging brain. I look forward to you joining me again for Seminar 6. Thanks again for your attention. This is Steve Saltwick.